Welcome everybody. Like I said, sorry for technical problems at the beginning. Welcome to my talk, GraphQL versus traditional REST API. Thank you for choosing this talk. I know there's a lot of good talks at the moment, so thanks for choosing mine. Okay, start. So, first of all, let me introduce myself. My name is Vladimir Dejanovic, and I am part of a professional IT scene since 2006. In other words, I'm getting paid for work I do since 2006. I'm a founder and leader of AmsterdamJUG user group, and also I'm a speaker at conferences. But enough about me, right? So, what this talk is going to be about? First of all, we'll spend some time talking about REST, and what traditional REST is, and what we think when we say REST. After that, I'll spend some time about GraphQL, what GraphQL is. After that, I'll basically start comparing them, traditional REST APIs and GraphQL. And at the end, there will be some time for questions. So if you have any questions, please wait until the end and ask them then, or you can always ping me over Twitter, send me the mail, or catch me after this talk. So, what is REST? When for some API we say it's a REST API. And this might sound like a silly question, right? We are developing REST APIs for a long period of time. A lot of people are writing them, right? So why should I start with a question like this? Well, reason for that is that if I would really ask this question, I would get a lot of different answers, and most of them, unfortunately, would be wrong. And the reason for that is the REST has a very formal definition, since it was part of doctoral dissertation by Roy Fielding in 2000. If you want to read the whole doctoral dissertation, just follow this URL. It's a very good read, but be warned, it's not a short one. It's, in the end, it's a doctoral dissertation, so there's a lot of pages there. So we don't have a time to go through it all. We're just going to look in a nutshell what REST API is. So for something to call REST API, it needs to be client and server. So basically, there's a separation of concerns. Statelessness. Wow. Oops. Statelessness. Basically, it means that the server doesn't know anything about the client, and basically, there's no state of a client. All the data the server needs to respond to the client needs to come in request. Cacheability. Server needs to be able to actually say if the response should be cached or not, and for how long. Layered system. Basically, the client should have no clue if it's talking directly to the server or it's going through multiple layers before it's reaching the server. Code on demand, well, it's optional. In theory, it just means the server can send some code to the client to execute. And last but not the least, that we have uniform interface. Basically, it's very long stuff, but in a very short way, there is basically possibility for different parts of system to evolve independently. Okay, that's all nice, but again, my clients don't care about doctoral dissertations and theories, and I assume that your companies also don't care about that. They care about the code that works, right? So what do we think actually about REST when in real life? Well, usually it means there's some database, some data source, and then there's, of course, application which actually connects to that data source, maybe database, and expose this data via API. And it exposes to the front end, who actually consume API, and sometimes the data is sent basically literally like field by field. Whatever is in database is sent exactly as it is to the front end without any changes. These are so-called crude REST APIs, and they are very common. Of course, there can be much more complex situations, but this one is the most common one. So in most cases, when we think about REST in real life, this is what we think about. Okay, so let's look at some concrete example. So let's assume that we're building a blog. And basically, we have, of course, a table with authors and all the information that we need about the authors. Of course, we need posts, right? So we have some information about the post, like ID, title, body, author ID. And this blog is going to be very complex, so we also have option of comments. So basically, we also have comment with ID, text, post ID, and author ID. All the demos are written in Spring Boot and MongoDB as a backend, because I'm a very lazy person, and using them, actually, I can write the code very fast, and I can put bad stuff in it, and it's still going to work. So this is the URL where actually the code example is, and I'm going to use this URL throughout the talk. I'm just going to basically, as we advance, use different tags. So you can just go here and download whole code. Okay, so let's look at the code. First of all, let me just start this. Okay, so until this actually kicks in. So basically, this is my REST API, right? So basically, I have a Pojo, I have an author, which is exactly the same like a database. So it's author, there is ID, there is a name. So I'm using MongoDB and Spring Boot. So I have also repository, right? If it loads in, maybe it will, maybe it won't. Come on. Aha, here it is. So this is basically simple author repository. Like I said, I'm using Mongo repository, nothing fancy here. Also, we have posts, if I can type. So again, post exactly the same like a database, right? There's ID, author ID, title body. Again, there's post repository. Again, exactly the same, nothing fancy here. So the all work basically happens in controller. Basically, we have, like I said, REST controller. We have to wire some stuff that we need, and basically then we have some endpoints. We can ask for all the authors, get all the authors. We can ask author by ID. We can ask for all posts. We can basically filter them by author ID if we want. Oops, my bad. Okay. We also have options for comments, and also we can ask for comments by, I really need the mouse, by post ID. So if we go here, I can ask for all posts and get all posts. So if I want actually more information, for example, about the author, I can ask for author information. And if I want to have information about the comments for this post, yeah, just make sure that you all see it, I can ask, and I get all information. So again, it's a stupid example, but you can think about very simply that this can be sufficient enough to actually build the whole blog post with the whole front end and basically make it work. Is it the best? That's on the question, but again, it can work. Okay, so now that we know what the REST is, right? What is GraphQL? And I did exactly the same thing like everybody else. First time I heard about GraphQL. Basically, I typed in the Google, GraphQL, found the website, went to the read, started reading, and okay. And basically, this is what I read. GraphQL is a query language for APIs. Okay, but what does that mean, right? I had no clue. So I continued reading, and actually then I found the answer. And the answer is very simple, and that GraphQL is a specification. Nothing more and nothing less. And it is very important to remember this and to keep this at the back of your mind all the time. GraphQL is only specification. But we as developers, we don't work with specifications per se. We don't build our code with specifications. We use implementations of certain specifications to actually build stuff. And why you need to remember that GraphQL is a specification, again, when somebody builds implementation of some specification, they will maybe implement all the features of the specification, maybe they will not. Maybe they will actually be like, bite the book and do everything that specification says, or maybe they will just ignore it completely and do some things that they just want to do. So be aware that you're working with implementations. There are, of course, implementations in many languages. There is, of course, in JavaScript, in Java, in Go, in PHP, and new ones are being made all the time. In my demo, I'm going to use, of course, Java implementation of GraphQL, GraphQL Java, and I'm also going to use some other library just to actually make my code more simple and nicer. But again, talking is boring, right? So let's look at the code. Again, same URL, different tag. Oh yeah, I forgot to actually check out the tag. So. Yeah, I'm missing an L. Now you know why I don't do the live coding. Yeah, okay, so while this is starting up, let's look at the code. First of all, what I want to show you is I'm using exactly the same POJs. So the POJs are exactly the same. Backend is exactly the same. Nothing changed here. Using the same author repository, same post repository, also the same thing for the comments. So the backend, which actually talks to the database, didn't change at all. So if I go here, hopefully it's refreshed. Nope, it didn't. So refresh. Yes. It should really work better, right? Okay, so here is the most important part about GraphQL, the schema. So here, basically, I'm defining the schema for GraphQL, and here I say, okay, I have a type of author, whatever that type means, and basically I have field ID of the type ID. You see here I have exclamation mark. This basically means that this field is mandatory, so it must be there. Then I have a name, which is of type string, and if you remember, this is exactly the same like a table, exactly the same like a POJ, so it's like one-to-one. There's no differences. The similar thing with the post. Again, I define type post. Again, ID, title, body, author ID. Again, exactly the same like a POJ, exactly the same like a database. No changes at all. The same thing for comment. Again, I have type comment, field ID, author, post ID, and text of type string. And now we have here certain things which we don't have in the database, and that's like basically schema, query, of type query. Basically, this one here is the heart of your schema, and basically the heart of GraphQL. Basically, this is where you actually say, okay, above are the types that I will have, but this is basically with what you're going to interact with me. So I'm here basically saying, okay, I have a thing which is called query that will interact with me, and of course, because it's query, it's read-only. And it's going to be type of query, and here below, I define type of query exactly the same like all other previous types. I have all posts, and it will return array of posts. And now actually everything comes in place. So basically, I have a backend, which is exactly the same like in a REST API. I have this GraphQL schema, so then like how we actually connect one to another, like how do we actually wire them around. So in order to do that, first of all, I'm going to basically, so let me show you, because I'm using the Spring Boot application. Basically here below, I define the servlet. I register the servlet. This is the standard Spring Boot servlet registration, and I just said, okay, just on this endpoint. So whatever is coming for this endpoint, just send it to my servlet, and that's it. So let's look at my servlet. So again, like I said, I'm using a lot of libraries to actually help me, so I don't have to write boilerplate code. So my servlet extends simple GraphQL servlet, and it's going to do almost all work for me. There's only a few things that I need to do. And I need basically to create this builder schema, and I'm going to basically here say schema parser, right? New parser. I'm going to provide it with a file, basically say, okay, this is the file where my schema is. And then basically I need to help it actually wire the schema to the Java code, and for that I have resolvers. Or actually say, okay, like use this resolver, new query. We'll look into it later. After that, all that I need to do is say build and make executable. And that's it. So a very small amount of code. So let's look at the query. So for query, basically, first thing first, it implements GraphQL root resolver. It's implementing GraphQL root resolver because if you go back to the schema, it is on a root level. Another thing, it's called query, right? And here, no, in schema, go away. In schema, this is also query. This is not coincidence. It is on purpose. So basically that my Java code knows how to map and basically wire Java code with the schema. Again, here in the schema, I have all posts, which return array of posts or list of posts. So if I go back to my query, you will see I have a method called all posts, which actually return a list of posts. Again, this is not by coincidence. This is how actually I tell my Java code how to wire and connect to the GraphQL schema. Okay, so let's look how actually, okay, this is started. Let's look actually how this looks in real life. So maybe this is too big. Good enough? Yeah, okay. So basically what I can do is type here query, right? And then I can actually request for data, and I can say all, and you can see I get autocomplete out of the box. By the way, I'm using GraphQL, which is basically like a playground front-end client that you can actually use for testing your GraphQL applications. So if I say all posts, then I can get ID, I can get title, I can get body, and I can get author ID, right? So all the fields that were actually in the post. And if I say run, yeah, of course, I get the data. So far, so I would say like, yeah, but we already had that in the REST API, so what's the point? Well, the one nice thing that actually you get here for free is that I can say, let's, for example, I don't care for the body and author ID. So I just want ID and a title. And here it is. So I can actually do filtering out of the box right away. Another nice thing that you get for free is basically this documentation. Because, and you can see basically here in documentation, okay, I have a query, which will return type of query, which actually has method all posts, which will return post. If I click on the post, I get all the fields for the post. So there is some nice features already, which we can use. Okay, so let's just do a quick check, basically how actually the GraphQL compares to the traditional REST APIs, or actually REST API definition. So is the client-server architecture? Well, yeah, I showed you I have a client and I had a server, so it is. Is statelessness? Well, I used very simple standard Java servlet, so yeah, if I write my code in correct way, it is. Cacheability, again, the same thing. If I write the code in good way, it is. Layered system, yes. Code on demand, well, it was always optional anyway, so who cares? Yes. And uniform interface, well, I showed you the schema, right? So I would say a big yes. So I could basically very simply argue that the GraphQL is nothing more than a REST API. And it's basically according to definition, it is. It's a very advanced API, and we will come back to that. But we can argue very simply that it is a REST API. It's a very short talk, right? So let's look at some other things. So basically with the REST, schema is optional. You can build it, you can have it, you don't have to have it, it's still going to work. You can first write the code, then from the code generate the schema. You can first write the schema, then from schema generate the stubs and actually add your business logic, or you can completely ignore the schema. You can do whatever you want to do. It is extremely good practice to always have schema, and my suggestion is always have schema, but again, if you don't have it, everything will work. And this is the first big difference between traditional REST API and the GraphQL. With GraphQL, schema is mandatory. You must have schema. So you can either do what I did, create a schema and then basically create a Java code which is going to be mapped to the schema, or you can write the code for which you're going to generate the schema. But either way, you have to have schema. And the reason for that is very simple. So if you have a client and a GraphQL API, client basically on the first initial communication with the server will get back the schema. And the GraphQL API will say, okay, this is basically how the response, how requests should look like and how response will look like. Client can then basically store that information somewhere and make sure that every request that client sends to the server is correct, is according to the schema. Because, you know, like, why would you send something which you know is not valid? Again, if you want to play dirty and you actually force the client to send invalid requests to the server, what's going to happen is that the server is going to respond right away as an error. Because the server is going to take a request, compare it to basically to the schema, is it valid or not? And if it's not valid, it's not going to do any work. It's just going to say, it's not valid request, go away. If we talk about advanced APIs, we have to talk about HeatOS. The idea behind HeatOS is, in origin, very simple. And that's basically that you are building an API which is self-explanatory and explorable. If you think about it, like if you go to a certain website, you don't really know a lot about the website, right? You just know the main URL. But when you go there, then there's links, there are pages, you can go from one link to another, you can explore the website. So the idea behind the HeatOS is very similar, but for APIs. So, oops, yeah. So let's look at how actually that looks like in a GraphQL case. Okay, so while this starts up, we can look at the code. Okay, no, actually, where's the schema? Yeah, okay, so I changed the schema very little. I changed basically only this line here. So basically, where actually before there was post author ID, now I said post created by author. And is this sorted? Yeah, so this is up and running. So if I go here, and now I need to basically refresh, so that basically my client gets the new schema. I can say here, created by, and because I get the full author, I can say which field someone, for example, name. And voila, it works. But how it works? Is it magic? Of course not. So if we open post, it's exactly the same like it was. So no change here. If we open post repository, again, exactly the same thing, no change here. If we open the query, where actually was responsible for reading the data, again, it is exactly the same. So from where I actually got the new field? Well, for that, we need to go back to GraphQL servlet and see that here I have a new resolver. And this new resolver is basically called post resolver. So let's look what actually this resolver is. So if you check here, it implements GraphQL resolver of a type post. So if we compare it to the query, in case of the query, it was a root resolver, while here is GraphQL resolver. So that's the difference. Also here we basically have a type post, which actually, and then here you can see that there's a method called created by. Again, the same name like in the schema, and this not by case. It takes post as an argument and sends back the author. So basically this is the way how you actually wire your GraphQL schema when you basically in Java code, and actually how then your Java code knows what part of the code needs to be called in order to resolve your fields. Cool thing about this feature is that if I go back to my example and I say, okay, in this case, call it like this, right? So I only ask for ID and title. This created by method will never be called. So it will be called only and only when somebody actually requests this field, which is a very cool feature. Okay, so basically what I did in the past was we had something like this, right? I had my client, and my client could only see the post, while the author and the comments were completely out of the scope. We couldn't access them. So basically then we created one connection between the post and the author, so then basically the client can ask, from the post, go to appropriate author, but why stay here? We can create connection from the author to the post, from the post to the comment, from comment to the post, and from the comment to the author. So now it looks like a graph, right? So now you actually get from where actually the GraphQL name comes from. So let's look at the code again. Same URL, different tag. Okay. So what's going to basically to happen now is, okay, where's my schema? Now I really changed schema a little bit more. So basically now with the author, I added posts, which is a list of posts, which basically of course is like all the posts of this author. Then in the post, I added comments, and basically all the comments are connected to this post. With the comment, basically I added field created by for the author, right? For which basically to which author basically this comment, who created this comment, and also have to which post this comment belongs to. If I go to my GraphQL entry point, we can ignore the reds because it's working. Basically you can see, just go away, that I added another author resolver and I added comment resolver. Again, they're very similar to the post resolver, which I already showed you. Exactly the same thing. So if we go here now, I can actually say, okay, yeah, again, I need to refresh just to get the schema. Okay, so basically I can say here comments. I can say, okay, text, right? I can say created by. I can create name. And I can ask for posts. I can say for title. And this all works. So now it becomes even more advanced. And this is basically what I thought, basically when I said that GraphQL is very advanced API. Okay, so if we go back now to the definition of GraphQL is a query language for APIs, now you actually understand what was meant by that, and also I, right? And this is not coincidence, because original idea behind GraphQL was to be used like this. So basically that you expose only one endpoint, basically GraphQL endpoint, to the user, while in the backend you have multiple systems. You have a databases, you have some other legacy systems, you have some other APIs, and basically through the GraphQL you just say, okay, this is the objects basically that we have, this is the objects that we will expose to you, this is the objects and connections between them, And basically, you ask whatever you want to ask. And again, because the GraphQL has such a powerful query language, it allows it to do so. And this is, again, one big difference between GraphQL and a traditional REST API. Because with the traditional REST API, you really need to think hard. Okay, how the users are going to interact with my endpoints? What data do they get? How they actually, which fields they want or don't want? With the GraphQL, you just say, okay, here is what I have. Do whatever you want to do, which is very powerful. But again, that also means that your users have a lot of power at their fingerprints. And that's basically what you have to remember. Because with the GraphQL, basically the clients call the shots. And again, this is the big difference compared to traditional REST API. Because if you think about traditional REST API, you know exactly where your users can go and how they actually go. With the GraphQL, you have no clue. You only know what's exposed. But again, will they call the resolvers or not? Will they ask for created by or not? You don't know. So there are much more ways that actually they can interact with your API. So why is this important thing? Well, if we go back to this very simple example, right? You can see here that here's basically the cycle, right? I can go in circles, which means that somebody, by mistake or on purpose, can write query like this, and I would like to stress this part here, which means that somebody can actually create an infinite loop or ridiculously long query, which is going to be absolutely valid. And again, if you run something like this on my current example, it's going to crash. And that's not what we want, right? And that's basically one big danger with the GraphQLs that you need to be aware of. So the logical questions comes, okay, but how then we protect ourselves from the abuse, right? What should we do? Well, the simplest thing that you can do, and simplest answer is just to do the timeouts. But the problem with the timeout is, although the client will get a timeout, your server is still in the back going to use CPU and memory and going to crunch the numbers and can go haywire. So that's not good, right? So much better thing that you can do is actually limit the maximum query depth. If you remember what I said, at the beginning, basically what the GraphQL does is basically take the API, basically your request, and checks it according to the schema. Is it valid or not? So during that check, you can also check, okay, what's the maximum depth of the query, and if it's above a certain number, just say, okay, this is too deep, I'm not going to run it, go away. But again, this is better, but users can still attack you in the width. So for that, even better solution, but more complex one, is to actually do max query complexity. For every query, you add certain value and say, okay, this is the complexity of this query. And basically, when you actually do, again, static analysis of the query, if it's valid, you sum all the numbers. And if it's above certain weight number, you just say, okay, this is very complex. I'm not doing it. This is more complex to implement and even more complex to maintain. So be aware of that. The best possible solution that you can actually do, but again, most complex to implement, is throttling. Basically, every few periods of time, give certain amount of memory and CPU to every request, and in this case, everything will work good. But implementing something like this is the most difficult one. And again, we then come back to the thing that the GraphQL is a specification. Certain implementations have some protections like this already baked in. Some don't have any. So you need to know implementation which you are using. Does it have some protection or not? If it doesn't have protection, then you need to build it yourself. GraphQL is a query language for APIs, and it consists of 3 big parts. The first big part is basically the query, which should be read-only, unless you're not naughty. And we already saw it, right? I showed you multiple examples of reading the data, but let's be honest. If you can only read data, it's not going to be very fun after a certain period of time, right? We need to change data. That's why we need mutation. First difference between query and mutations, except of reading, of course, changing the data, is the fact that because query is read-only, when you actually send multiple query requests, they will be run in parallel. In the case of mutation, because they're changing data, they're going to be run sequentially. Again, let's look at the code, because the code is much more interesting than this. Oops, I forgot to stop it. Come on, be faster. Docker is fun for demos, but again, it's sometimes very slow. Okay. So if we go to the schema, basically you will see that here in the schema, like I said, the heart of a GraphQL, there is this thing here, mutation of a type mutation. And below, I have type mutation, which has like basically two things. Add author, which takes parameter name of a type string and returns back the author. And we have remove author, which basically has parameter ID of type ID and returns back the author. So important thing that you need to stress here is query and mutations. You have to use those names. You can use whatever name you want. As long as your Java code and schema are one-to-one, everything will work. But for sake of everybody else who comes after you and read the code, please use query mutations so that everybody knows what it is. Also, here I'm basically adding the parameters to the mutation. In the same way, you can also add parameters to the query. So the same thing, it will work automatically. Also, it will work in the same way. So if I come back to my servlet, where all my resolvers are, basically I have new resolver called mutation, which is of type, again, implements GraphQL root resolver. So exactly the same like a query. So from Java point of view, there is no difference. They're both doing the same thing. They have just different names. And here, of course, I have basically the method add author, type string, name, and we'll return the author. And the same thing for remove the author. So let's look at how actually it in the demo is going to look like. So I can just do mutation. I can say add author. And I can say, I can put name. And I get back ID and name, run it, and here it is. It works. I should probably I can also remove it, but I don't want to remove it now, so I can also edit all authors. So you can also see it here, right, that it's there, and I'm not cheating. So they're all here. And that's all that is needed, basically, for doing a mutation. So it's very simple. The third part of a query API is basically is subscription. Idea behind the subscription is basically that client comes and say, okay, I want to subscribe to this type of messages, and then the server basically sends a continuous stream of the messages. Again, this is not implemented with all implementations, so that's why you need to remember that you're dealing with implementations and what are limitations of it. There's probably some questions that you're going to ask yourself regarding to the GraphQL. First is, okay, but what do we do with errors, right? With traditional REST APIs, we know we usually use different status codes and different things, and basically according to that, we had some logic. Well, the good thing about the GraphQL is that it's specification, so somebody already thought about it for you. So if I go back to this one here, you will see here we have a data, right? But if I add here something which doesn't exist and send it, I get an error. Basically, that's the way how you deal with errors. In every response, data means there is data. If there's error, that basically error will be there, and whatever is there, basically you can deal with it. Of course, you can customize these errors. You can make it however you want to do. But you don't have to go to square one with errors. The other thing that you can probably ask yourself, okay, but what do we do about performance and cache? Because again, if you think about the code which I showed you now, imagine that we have basically one author who wrote thousands and thousands of posts. Basically, my code will actually get the author data 1,000 times. So it will be very chatty. GraphQL basically doesn't care about that. GraphQL is just specification. So basically, it's up to you to think what you want to do and how you're going to approach this problem. Maybe implementation that you're using already thought of that, maybe not. Again, from the GraphQL point of view, it's up to you. A similar thing is with authentication and authorization. Again, GraphQL as a GraphQL doesn't really care. It's basically up to you and the implementation that you're using. What I saw is that most basically applications and implementations are just using the context as simple as any other API that basically is standard there. Again, maybe there will be need for some little bit more work from your side, maybe not. Again, depends from what you use. But it can be done. Okay, so let's recap a little bit more about what we just went through all of the things. First of all, as you saw, the GraphQL and traditional REST APIs are very similar. They're extremely similar, but again, there are differences between them. And some of them are not really small. When we come to tools and knowledge, we have to acknowledge a very simple thing, and that is basically that REST APIs, as we know them, are being built and written and developed for a long, long, long time, even before the doctoral dissertation of the Roy Fielding. So the knowledge that people have, the amount of tools and libraries and frameworks built around it, and all the things that actually support you with that is huge and enormous, and that's something that you should never overlook. When it comes to the GraphQL, it is much younger technology. There isn't that much knowledge, there isn't that much tools and libraries and frameworks to do everything for you. But again, they're catching up with the speed, and they're becoming better and better and better. Important thing also to remember is that, again, because the REST API and the GraphQL are so similar, a lot of old tricks and knowledge that we actually have from traditional REST APIs, we can very easily use when it comes to the GraphQL. Most of the tools, for example, especially for example the caching and the responses, authentication, some of them we can even use like one-to-one. For some, basically we just need to change small parts of the code and basically think a little bit out of the box, but we can reuse those to actually solve a lot of problems. Again, when it comes to the GraphQL, GraphQL has extremely rich SDL or schema definition language. I didn't show you all the features from it. I only showed you like small part of it. There's also like ways that you create unions. You can define the new scalar types, and basically you can do a lot much more than actually I showed you. And when I compare it, for example, with OpenAPI or Swagger or RAML or basically API Blueprint, the GraphQL SDL is much, much richer, and it gives you much more power also as a backend developer to actually express whatever you want to do in a much nicer and concise way. Again, GraphQL has extremely powerful query language. Again, I didn't show you, I showed you maybe half of it. So basically you can also create like the snippets of the code which you can reuse in the queries itself. You can basically change the responses and the fields in the response. You can forward basically the request and basically create like arguments and variables and send them through the queries. You can have even conditional basically parts of the query where you say, okay, like if certain feature is like true or false, also ask for this part of the code or that part of the code. So it's basically, it's extremely rich. And again, like I really encourage you to actually go and read a little bit more, because I showed you a very small part of it. Thank you. We have questions, right? Oops. Okay. I can't answer this first question because the lawyers from ING is going to kill me, so please don't. Well, it is valid JSON, kind of. I'm not sure that I understand the question. Why it's not? Can the person who asked this question answer a little bit more with the logic behind it? Because you send across basically the JSON. So basically, if I go back, where is the thingy? Yeah. So if you just web developer networks. So let's say just I remove this stupid thing, right? Reload. There should be somewhere here. Yeah, so basically, here is the response. So it goes over JSON. So, sorry? Request also JSON. Request, yeah, request. So if I send request, where's the? I just need to find where is parameters. So yeah, you see again, I send, well, sort of. It's basically it's JSON with the query, and basically a variable. So it is using JSON underneath. Okay. What are the bad attributes in GraphQL? Well, the bad attributes of GraphQL again is that it can be abused very easily, like I showed. So you can very easily shoot yourself in the foot and kill yourself, and without even knowing that. So that's why you need to understand when actually you create some GraphQL, basically API, what is in the background, how it's actually being executed, what's working. So you don't have to really know it in the very big details, but to have at least overview so that you actually know where you actually need to protect yourself. Also, so say like testing it fully is a little bit more complicated compared to traditional REST APIs, because again, in traditional REST APIs, you know all the endpoints, you know all the parameters, so creating all the variations of that is much easier compared to the GraphQL, where you have basically unlimited set of possibilities. So that's, I would say, is weaknesses and problems with it. Okay, where we can use GraphQL effectively, which problems does it solve? Well, GitHub already has it, Pinterest I think already has it, so a lot of Facebook of course already has the GraphQL, so if you're building any tool which basically talks to them and using their APIs, you can already use GraphQL out of the box. You can also create basically your own GraphQL server and basically then use it there. The biggest problem basically that GraphQL actually solves is ability for us in the backend to actually define, okay, what are the types that we're exposing, what are connections between them, and basically give the whole power to the front-end users, instead of going from constant iterations, okay, what things I want to expose, how am I actually going to connect it, how should I basically connect to them. And again, you can build what GraphQL is giving you for free, actually. Yeah, what actually GraphQL is giving you, you can build it yourself without using GraphQL at all, but then you need to think and agree about a lot of things. Basically, okay, how you're going to structure methods, how you're basically going to seek when you want to filter stuff, how you're going to basically, what's the language is going to be between the front end and our back end. And again, like I've been on worked on some APIs which actually, where we did that things, and again, I can tell you from experience, it's not really fun. So whenever you can actually use some good specification which already solved a lot of problems for you, my suggestion is use that one, because there's less things for you to actually worry about and to think about, okay, what should I do here? Again, you don't have to use GraphQL to achieve what GraphQL is giving you. You can build it yourself from the bottom up or do whatever you want. But then you need to go through a lot of iterations and thinking about a lot of use cases that people basically on Facebook who actually developed GraphQL and outsourced it already thought about and basically came up with some best practices for it.